Okay, so we're starting with part C where we're figuring out how much money you'd make if you are compounding annually once a year and then compounding quarterly. All right. And now it's basically just using the calculator. 1,000 times 10. Oh, let me go back. 1.02. And we're raising that to the fifth power for 5 years. And we're talking about money, right? So that would be $1,170.57 because it's money. Anybody else get that answer? Yeah. Okay, so after 5 years compounding annually, do you think it'll be more money if you compound every quarter? Or should it be the same? Because we worked out the equation so it maybe evens out, but let's check. So this one was annually. This is annual. Now let's look at quarterly. Okay, so this is f of 5. And now we're using this version. $1,000, 1.0079. And we have to be careful because this is the part that's different now, remember, besides the rate. This is 4 times 5. In other words, it's not to the fifth power, it's to the 20th power. Okay, this is 4 times 5. So let's see what that is. Let's all try it. You got $1,000 times 1.0079. And that's going to be raised to the 4 times 5 or 20th. What do you notice? The other one was a 1,117.57. This is, did anyone else get the same answer I did? $1,100 and not 17 but 70. And this would be, remember, we're talking about money. We're rounding to the nearest cent or hundredth. 44 or 43 cents. 44. So you made a little more, not a whole lot more, compounding quarterly. Okay. Let's try the next one. It said, Sadie will need to withdraw her money after 5 years and 2 months. Which compounding period would be the most beneficial for her for her account? Well, 5 years and 5 years, 2 months. Out of these two, which one do you think would be better? How often do you get interest with the annual? How often do you get your interest? Huh? Every 12 months. How often do you get your interest this way? Yeah. Basically, they break it up into, well, if you break up a month into 4 parts, how much is each part? How many months? 12 months. 12 months broken up into quarters. 3 months. So this is every 3 months, right? So how can we tell? How can we figure that out? Okay. Oh, they also want us to consider the monthly. Why don't we use this one and figure out how much you would make monthly? Because what you would make would be a little more than this, like maybe $1 more, if that. Let's figure out how much you would make in 5 years and 2 months this way. Okay. So this is going to be 12 times our time. So let's use this one, see how much she makes. Um, First of all, if it's 5 years and 2 months, how much is that maybe as a decimal? How could we figure that out? Or as a fraction? It's 2/12, 1/6. So that's going to be a repeating decimal. So we're going to figure that out. Okay, let's go ahead and do that. Let's do f of f of, I want to think about how much that is. What's 5 plus 1/6? Let's do a quick little calculation here. 5 plus 1/6. Let's see. That's 5 and 1/6. Let's convert that into an improper fraction. How much is that? Yes. 31/6. So this is 5 years and 2 months. So we're going to use 31/6. Okay. See? Knowing your fractions helps out. Okay. Now we're using the monthly. And this is going to be 4 times 31/6. That's 31/6, by the way. Okay, let's see if we can't do this. 1,000 times 1.0026 raised to the, I'm going to add another parentheses here because I'm going to let the calculator do this. Okay, you ready? This is how I'm going to do it. 4 multiplied by, I'm going to add another parentheses because I'm going to make the fraction 31/6. Close the parentheses to finish the fraction. Close the parentheses again to finish the power. And if I did this out correctly, it would tell me how much that is. Oh, did I multiply by 4? Yeah, it's 12. Sorry. I was still stuck on the quarterly. Let's try that again. 1,000 times times 1.0026 raised to the parentheses 12 times, you can put times, and then I want 31 divided by 6. Close the parentheses for the fraction, close the parentheses for the multiplication. And what do we get? 1,074 and 67 cents. 1,174 and 67 cents. And I think that's the best we can do. And that's a monthly. So you get a little bit more compounding monthly. And if you compound it by day, it would be a little bit better still. It's, a few pennies more, but hey, it's extra money. All right. So let's take a look at number 5. The amount of medicine remaining in your body each day after taking the medication can be represented by the exponential function shown by the graph. So it's true. The decay or the amount of the medicine that goes out of your system is exponential decay day by day. It's saying, at what rate is the amount of medicine in the body changing? Well, let's see if we can't get some values. How much medicine was in the body in milligrams at 0? 60. Now, if we're using this one, what would be another good value to pick, or the best value to pick, if I want another ordered pair to work with? Yeah, when days is 1, and that would be 130. You want them to be consecutive. You want them to be consecutive because if I pick this one, 2 and 15, then obviously you have to do that little trick that we did with a square root. We don't want to do that. Okay, so B, basically what they're asking us, how do we find that? It's a ratio. 30 over 60. I think it's safe to say that's 0.5. So at what rate is the amount of medicine in the body changing each day? It's dropping. What percentage? Yeah, each day you have 50% less than you had the day before. Okay. So now they want us to write a function. F of x. Let's do it. I think we have all the information we need here. We know the a value, it's right there. We know the b value, we just calculated it. Write the function. Check in with your partner. Okay. So it's going to be, see if you get the same thing I do. There we go. So based on this graph and the data we got from this graph, this is how it's dropping daily. It's decaying daily by this much. All right. Write an equivalent function and estimate the hourly rate at which the number of milligrams of medicine in the body is changing. How many hours in a day? 24 hours. And right now, this is daily. X is daily. So what we have to do is something like this. Okay? So I'll get you started and I'll let you work with your partner to figure this out. So it's still going to be 60. 0.5 to begin with. Leave some space because we're going to put something in here. Because what we need is, since it's, you want to do it 24 times, you need something here in place of that to compensate for that. What did you say? 1/24th. So now our job is to figure out what the 1/24th root of 0.5 is. So definitely, I mean, I'm good with my numbers, but I don't know the 24th root of 1/2. But we can easily figure it out like this. Let's round that to the nearest hundredth. What would the number be? 0.97. So now we can just write it. F of x equals 60. And then instead of 0.5, it's 0.97 to the 24 times x power. And that would give you hourly. Okay. So that's the end of it. Go ahead and work on, I'm going to give you the worksheet first, and then go to Delta for the second part. That probably will be homework.